Hello everyone and welcome to my YouTube channel. In this channel, I want to share my love of chemistry to everyone else as a chemistry student myself. So, yeah, let's get started. So the first lesson I'll be covering is the atom and the periodic table of elements. Two of the most important things in all of chemistry. So let's get started with the atom. The atom is a building block of matter because everything in the world is made up of atoms. Looking around, there's nothing in the world that is just not made of atoms. The atom is composed of three different subatomic particles, which are the electron, the proton, and the neutron. In the middle of this atom are the nucleus, which is where the protons and the neutrons reside. In this figure here, we can see that this assortment of red and yellow balls is a figure representing the nucleus, where the red, in this case, represents protons, yellow represents neutrons, but it can be interchangeable. The protons and neutrons are different from one another. Protons, first of all, have a positive one charge, while neutrons are neutral, meaning they don't not have a charge at all. On the outside, in these rings slash shells, are the electrons. The electrons are much smaller than both protons and neutrons and have a negative one charge. They are held together with these shell-like patterns orbiting the nucleus. So you're probably wondering, how are the protons and neutrons held together in the nucleus, and why are the electrons just orbiting on the outside? Well, this is because of the strong nuclear force, which is one of the four forces of the universe. The strong nuclear force is what holds these protons and neutrons together in this nucleus shape so that the electrons can revolve around the outside. You're probably wondering, what is the rest of the atom composed of? Well, this is it. The rest of the atom, like this space here and this space here, is just empty space. There's nothing else in the atom. This is all that is composed of the atom. So, how are the elements different? So, every element has a different composition of subatomic particles, meaning hydrogen, for example, will have a different combination of protons, neutrons, and electrons as composed to oxygen. The number of protons determines which element the atom is, which I will dive deeper into in our next section. So let's move on into the periodic table of the elements. A quick background about this table is that it is an arrangement of elements by Dmitry Mendeleev in the 1800s. So a very long time ago, this was created. And while it may look random at the start, the position of every element is very important, and it was definitely not randomized. Let's start with the basics. So first of all, we have the groups. Groups are vertical columns of elements, meaning this is a group. So these are groups. On the other hand, we have periods, which are horizontal rows of elements, meaning a period would be here. These both play a very crucial role in chemistry. For example, each element in a group has a very similar chemical property to one another. For example, that would mean that potassium and sodium have a very similar sense of reactivity, while on the other hand, with periods, these represent the energy levels or the shells of electrons, and every element in the same period has the same number of shells. So looking back on our first image, we see that there are two shells, 1 and 2. Therefore, that this must be in period 2. And looking at this, period 1, period 2, meaning that this atom up here has to be in this period. These are both incredibly important, and I will discuss about them in future episodes as well. So now let's look at the periodic table. There are different types of states of matter that the elements share. For example, everything on the left of this staircase that I've drawn, the staircase usually appears in most periodic tables. Everything on the left of this is called a metal. So, metals. While on the right side, on the right hand of the staircase, excluding hydrogen, we have the non-metals. And in the middle of the staircase are the metalloids. Metalloids. So what are metals, nonmetals, and metalloids? So basically, a metal is when everything on the left of the staircase, which are the metals, are solid at room temperature. So room temperature, which is 64 to 75 degrees Fahrenheit or 18 to 24 degrees Celsius, meaning that at this temperature, it would be a solid element. On the right-hand side, the nonmetals are gases at room temperature. And the metalloids, which share properties of both metals and nonmetals, tend to be also solids at room temperature along with the metals. So let's dive deeper into the groups. The groups of elements are really going to be the most important and most valuable things you need to understand in beginner chemistry. Let's start with our first group, Group 1. This group is called the alkali metals. Alkali metals. The alkali metals are incredibly reactive, and they react with almost anything. They are some of the most reactive metals in the whole periodic table. Second of all, we have the group 2, which is called the alkaline earth metals. Alkaline earth metals. This group of metals is also pretty reactive, just not as reactive as the alkali metals. These both play an incredibly important role in bonding, which I'll talk about in a later episode. Next up, we have the transition metals, which range from this box around here. These elements are very unique, and that reason I'll cover as well in a later episode. So that's most of the metals. These on the bottom are called the lanthanides and the actinides, but they're not so important for beginner chemistry. All right, so let's move on to the gases. One of the most important groups of gases is the noble gases, group 18. These elements do not react at all. It takes a lot of energy to force them to react, and they tend to just stay alone. Second of all, the last group I will be talking about today is the halogens, which is group 17. Halogens. Just quickly move that. Yep. Halogens. This group is also incredibly important because this group, the halogens, tend to react a lot with the alkali metals that I mentioned earlier. All right, so let's talk about these boxes, which is going to be the last thing I talk about today. What are these numbers, letters in these boxes? So first of all, this top left number on all elements is called the atomic number. Atomic number. The atomic number basically helps in determining how many protons there are in this element. So this means that in hydrogen, there's 1. The number of protons helps determine helps determine what the element is. So if I was to say, well, if there are 27 protons in this element, what element is it? Well, I would look on the periodic table, look for 27, and see, oh, that's cobalt. Next of all, we have this letter. So we have H. This is the element symbol. So the element symbol is incredibly important because every element has a unique element symbol. Some are easily understood, such as O for oxygen, but some can be harder, such as Fe for iron. Lastly, let's look at number written underneath. So this number here, this is known as the atomic mass. So the atomic mass is the sum. Atomic mass is the sum of protons plus neutrons. That's one way. That's how you find the protons and the neutrons. Well, you already know the protons, so this would be how you find the neutrons. For example, if we look at nitrogen here, we see it has an atomic mass of 14, because you round. So 14, and you know there are 7 protons, so 7, and then neutrons, let's take a variable, n. So that means there are 7 neutrons in nitrogen. While that makes sense because there's 7 protons, but that's not how it goes. For example, if we look at potassium here, it rounds to 39, there will be 20 neutrons. So there are generally more neutrons. However, if you look at electrons, the atomic number also reflects the number of electrons, because the number of protons has to say is always equal to number electrons in a pure element which has not had any reactions yet. This is so that the element stays stable and it's in its most stable form. Last thing that I have to mention is that protons and neutrons both have a mass of 1 AMU, while electrons are incredibly small, so they have a very small negligible mass. So how do we get these decimal numbers? Well, these numbers are actually of the atomic mass are found out from isotopes. And what they are is every isotope of the element is taken, and then the average mass is calculated of this isotope. That's how we find these numbers down here. I'll talk more about how to calculate those in a future episode. And that's it for today. Thank you all for watching my video. Hope you guys enjoyed. Like and subscribe if you enjoyed, and I hope you all have a great day.